Alright, so in this problem here, we have two satellites moving around two different orbits. One is a circle orbit in the center, one is a elliptical orbit on the outside. Now, the first satellite, A, is 60 degrees behind uh, periapsis, while satellite B is a periapsis. And I wonders how big does or what does the symmetric axis of B have to be in order for it to take a whole revolution and for satellite A to make a whole revolution and come back to periapsis, so they both meet at periapsis. So it means that the period of B has to be equal to the period of A plus a period of 60 degrees, and I'm going to call T60. Now, it's a circle, so how long will satellite A take to do 60 degrees? Well, since it's a circle, the amount that it takes for it to take to 60 degrees is simply going to be 60 divided by 360. So here we have TA plus, it's going to be, as I said, 60 divided by 360 TA, a whole period. It takes 1/6 to do a whole period, so we have TA plus 1/6 TA that is equals to 7/6 TA, and this TB. Oops. Now, what is the period of TA? Well, TA is simply a circle orbit with a perigee of 800 kilometers. Well, that'll be altitude of 800 kilometers. So the altitude of A at perigee is 800 kilometers. So we need to add the radius of the Earth. So there's about 6,371 kilometers, I want to say. So anyhow, this would be equals to 2 pi divided by square root of mu times A at the power of 3/2. And since it's circular, circle A is equals to simply the radius of the circle, and this is equals to HA plus RE. Okay, now we do this, we multiply by 7/6, so we get TB. TB is going to be the period of our um, B. Oh, we need to find the apogee altitude, but anyhow, we're gonna start to get the TB. We said is gonna be equals to 2 pi as well divided by square root of mu times A of B, so the same major axis of the satellite B at the power of 3/2, and A is simply equals to R A plus RP. So the radius of perigee plus the radius at apoapsis. So the radius at apogee and radius at periapsis. Now the radius of periapsis is going to be the same as the radius that we found before because they meet at the same point and both have the same periapsis. So it's simply going to be equals to A is going to be equals to, actually, sorry, we need to find RA, so it's going to be equals to A minus R, and we said A minus, then it's going to be HA plus RE. So these are A, and in order to rewrite the period for A, so this thing here, then we're going to need to do A is equals to TB, oops, again, TB divided by 2 pi times square root of mu at the power of 2/3, where TB is, we said before, 7/6 of TA. So TB, let's plug it in 7/6 TA divided by 2 pi times square root of mu, everything in the power of 2/3. And now this is going to be the A of our object B, and we said RA is equals to A minus that, so it would be so RA is equals to this whole thing here minus HA plus RE. As you can see, we know all the values. We just plug them in. I'm gonna, oh, actually, sorry. we haven't calculated all the values because technically we still have TA left like that. So let me rewrite. So we said TA is equals to this part here. So I'm gonna plug that in my equation. I'm gonna do it on the next page. So we have 7/6 divided by 2 pi, everything to the power of 2/3 times, on this a we said is equals to r, which is equals to h plus re, 3/2, minus ha plus re. Now we can start simplifying some stuff. This part here gets simplified, and then we're left with 7/6 of 1 over square root of mu. I'm gonna take out this part here. Because we have 3/2 times 2/3, so it's simply gonna be equals to h plus re. Then we have minus h a, where's this altitude a, plus re. Now I can actually simplify further. I'm gonna say it's equals to ha plus re times 7/6 times the power 1 over square root of mu minus 1. I could simplify further, but it doesn't really make sense. So now let's solve this. I'm gonna plug it in a calculator, and then I'm gonna show at the end. So let me cut that up real quick. I feel like I'm missing something around. No, everything. Oh, that's no. Yeah, everything's correct. For some reason, I feel like the units are a little off. Um, let's see. Okay, so let's recheck everything. TA is equals to 60. Oh, sorry, TB is equals to this thing here. This all the same units here, same units here. These are going to be the same units here. Now I solve this for A, which is simply going to be TB divided by 2 pi times square root of mu at the power of 2/3. That's fair enough. And TB is equals to this, so I just plug the same units in. Now as opposed to TA 7/6. Oh, and then I solve for H. Sorry, I then plugged it in from this formula here. Now TA, however, was equals to this. Oh, yes, I am missing a mu. Because here I had a times mu. So this thing here gets simplified here. Fortunately, that was a pretty quick check thanks to the units. And so I just have this part here. So I just have HA plus RE times 1/6. No, it can't be. Because then it would be smaller than HA and RE. I could have not simplified anything. It probably would have been the smartest choice. Oh, that's fine. Because 2/3, I forgot, it still applies to my 7/6. There we go. Okay, so I could rewrite this as, was it 2/3? Was it 3/2? No, 2/3, yeah. So when we have 7/6 minus 1, this is 2/3 times HA plus RE. And does it even become even smaller? Let's check it out. Oops. Create a new file. I call this exercise 2.17 IV1B. Okay, so and we said that it's going to be 7/6 at the power of 2/3 times, sorry, -1, all this times HA, which was 800 kilometers, plus the radius of the Earth, and we're going to say the radius of the Earth is equals to 6,371 kilometers. Yeah, okay. Something is wrong, but it's not gonna be. It's gonna be a smaller value, like I thought. Oh, that's why. Because two A is equals to RA plus RP. So this is gonna be a two in here. So I have to multiply this by two, and so we get a two here. Blah blah. RA is equals to two. Yes, yes. Two here and two here, and something's wrong. That is definitely not enough. I mean, that's 2A RA plus R, sorry, 2A is equals to RA plus RP. RA is equals to 2A minus RP, where RP is equals to HA minus plus RE. That's right. Uh, oh, because I guess that I did this R that I plugged in here is not the same. Plus H plus, no, it's the same. HRA. Yeah, that's even, I was solved it. These two should be in here. Um, okay, so in fact, oops. In fact, these, well, does he want the radius or does he want the altitude? He wants the radial position. No, sorry. There's the apogee altitude. So this is the RA, but he wants the apogee altitude. So I'm going to subtract RE, and it ends up being 2,352.28 kilometers. Let me take a screenshot of the code. I mean, it's two lines. I don't think there's really much to see, but like you can see it. We can see it makes sense with all the units because we only have units of distance in our formula, and the only units that these are all constants, so the only units that come from here. These are units. These are all distance units, so this is going to be a distance, all in numbers, of course. And we can see it makes sense because this one here is greater than the altitude at perigee, which was 800 kilometers.